so let's see what we can answer. I guess you would want to knock out the easy ones first. So what can we answer about this parabola without having to do any more work? Okay, where's the y-intercept going to be?
1.
It is going to be at 0, 1. Good. What else do I know about the parabola already?
It goes up or down.
Well, the parabola is not a minimum, but the parabola has a minimum value. The vertex is a minimum. Why does it have a minimum value?
Because
it's positive.
What's it?
The numbers.
When A is positive, that means that the parabola is going to open up, and therefore the vertex is going to be on the bottom. Therefore, the parabola has a minimum value. It does not have a maximum value because it's going to go up forever. So it has a min. No, Jason, don't get that?
No.
If I have this with arrows pointing up, how high is it going to go? Infinity. So it does not have a maximum value. It's going to keep on going forever and ever. There is no maximum. Numbers go on forever and ever. But this parabola does have a minimum value at the bottom at the vertex.
That's like the change of direction.
That's a change of direction also.
How we technically wrote that it was forever.
I guess so.
I don't understand what you're saying.
Like we added language. Like letters and stuff.
I can't understand what you're saying. You're wearing pajamas.
Why does my pajamas?
I don't make the rules.
It's really because he wasn't cool.
That's true. Still not cool. But I'm trying my best.
It's gonna be cool in time.
Yeah. For the street cred. What else can I answer here? What's probably arguably the easiest one of these to answer every single time?
AOS.
Range.
No.
No, the domain first.
Thank you. What's the domain always going to be?
A negative infinity to positive infinity.
Yeah, all real numbers. Negative infinity to positive infinity. Now we were pretty distracted yesterday, so I'm not sure if in this period I took this approach, but maybe this will help you put things in context. If we're trying to kind of keep a running tab of what we're doing here, even though we can't fully answer the range, we actually do know part of the range. We can take that right there and say, hey, if this is going to go up forever, and range means how far up and how far down, I already know that on the high end, this is going to go to positive infinity because it's opening up.
Okay.
And there's a bracket.
I do know also that there's going to be a minimum value, that there's going to be some low point that I'm going to reach. So yes, as Jason said on the other end, there is going to be a bracket. I just don't know how low though. I don't know what number's going to go there. Now, at this point, I cannot find anything else without finding the vertex. I have to find the vertex. So the vertex is going to be at h comma k. What was the formula for finding h?
Negative b.
Negative b over 2a. You're going to have to memorize that. So that's negative 4 over 2 times 2, which gives me negative 1. I'm not even saying necessarily that I recommend kind of always going back and forth, but I'm just trying to take a different approach to see if something will click for you. Just by knowing the h, I now know the vertex is going to be at negative 1 comma something, but I don't know the y yet. I don't know k. And I also know, as Elsie said, the AOS, which is, what does AOS stand for? It's going to be at x equals negative 1. Because it's always at x equals h. But to do anything else, I need the k. I think some other classes started having a better understanding of synthetic substitution, but we didn't get to practice it that much because we were very distracted yesterday. So let's try it. If you want to get this and plug it in for x, then be my guest. That's fine. I don't have a problem with that. But if you want an alternative, Elsie,
I'm not looking at the phone.
just look out. You can get that negative 1 and put it like on a little balcony.
Oh yeah.
And then we're going to write A, B, and C. And then we're going to follow this path. It's going to be kind of zigzaggy. We're going to go down, then up and to the right, down, up and to the right, down until we reach the bottom of the last column, and that's going to be K. Every time you go down, you're adding. Even at the beginning, Some people would say, oh, mister, you just dropped down A. And that's fair, that's fine. But really what you're doing is adding. What's 2 plus 0? If there's nothing underneath the 2, what's 2 plus 0? It's 2. Then I want to go up to the top, above the line to the next column. An analogy I've done before is imagine that this is Rapunzel up here at the top of the tower. So every time that the number needs to go above the line, it's because it has to be lifted by Rapunzel. Rapunzel has to bring it up. And I already know that every time I go up, it's by multiplying. You just got to know that when you multiply, you're multiplying it times Rapunzel. What's 2 times negative 1? Negative 2. Now I'm ready to drop back down again. What is 4 minus 2? Wait, but Mr. Romero, you said you're supposed to add. Why are you subtracting? Well, because it's negative. Adding a negative is the same as subtracting. 4 minus 2 is 2. And then again, every time you multiply, it's with the number up on the balcony to bring it up. What is 2 times negative 1? And then finally, 1 minus 2 is negative 1. So I now know that K is negative 1. That's the coordinate I was missing here. And that also fills in the range. Now let's go graph. This is supposed to be a graphing unit. Ruben's excited about graphing. You may not know this, but he has pictures of parabolas all over his wall. So first thing I want to probably put is my axis of symmetry or the vertex, either one. I'll just do axis of symmetry first. That's going to be at x equals negative 1. So I find negative 1 on the x-axis and draw a vertical line through it. The vertex needs to be on the axis of symmetry. If my axis of symmetry is here and I'm putting my vertex out here, I'm doing something wrong. The axis of symmetry always has to pass through the vertex. Jocelyn, where's the vertex at? It's like written on the board. It's on the board. Yeah, and it's also it's at negative 1, negative 1. How many points does a parabola contain? How many points does a parabola have? How many points does a parabola have? How many points does a parabola have? An infinite amount of points. That's why it has arrows. But of those infinite amount of points, how many have I asked you to include in the graph? 5. So I have 1 down, 4 to go. Sometimes, and if I can get through all these examples, I will get to one where this doesn't apply. But sometimes you have the benefit of an additional point. And in this case, I do. What other point do I already know is going to be part of this graph? What other point do I know is going to be part of the graph? Already, without any additional work. Huh? No, H and K is already there. It's the vertex.
Range? The y-intercept.
The y-intercept. I also know this is going to touch the y-axis at 0, 1. That's what this says. 2 points down. I can now use my axis of symmetry. I can use the fact that a parabola is symmetrical to say, hey, this y-intercept is 1 box away from that mirror, from the axis of symmetry. So I can get it and flip it over to the other side and put a point 1 unit away also. So that's 3 points down and 2 to go. But now I need to work again. Because I don't have any other points. I've tried different approaches. Look, this same synthetic substitution, you can use that to find extra points. I've taught that before. I've taught a formula for transformations before where you can just plug in numbers and it spits out where you have to plot. I thought that one was the best of the bunch, but when I got here, the kids were like, eh. So I've kind of adapted, and I'm using something that I think some other teachers here use a variation of, which is to say, okay, let's look at this from left to right. Okay, how those other than the vertex, Jocelyn, those 2 other points that I plotted, how far away are they from the axis? 1 unit. So I've already exhausted that. I can't use anything that's 1 away left or right. But I could go 2 away, I could go 3 away, I could go 4 away, I could go 5. You pick whatever you want. Whenever I find 1 on the right, then I can flip it to the left. If I find 1 on the left, I can flip it to the right. The further away you go, though, the bigger that's going to make your graph. So assuming that you don't want your graph to get too big, Let's just go 2 away. So I want to see what's going to happen either 2 to the left or right, it doesn't matter, 2 to the left or right of the axis. What's going to happen? Like, where am I going to have a point 2 away? Where am I going to have a point there that's 2 away? Where can I put that point? So the way you would do that is to get that 2 and say, all right, what type of a function is this? Part of the title of the lesson. Quadratic. So I'm going to get that 2 and I'm going to square it. What's 2 squared? It is 4. So once you get that 4, the only thing you have to do in addition to that is always multiply it times a. So 4 times 2 is 8. More importantly, it's a positive 8. So what this tells you is that if I go 2 to the left or 2 to the right from the axis, from the vertex more specific, I have to go 8 up. If it was a negative 8, it would be 8 down. But I have to go 8 up. Now, do not count from the origin. A lot of times you guys are used to plotting points from the origin, and you want to count from 0, 0. But no, here I'm going to count from the vertex. So I can go either 2 left or 2 right. It doesn't matter. But then I have to go 8 up. So if I go 1, 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8 up, that puts me at 1, 7. If I go 2 to the left and 8 up, or I can select, gives me the same thing on the other side. So now I can connect the dots. And I have my parabola. How are you? This 2 here, I picked it because I want to know what's going to happen 2 units away from the axis. If I wanted to put a 3 there and then square that, that would tell me what's going to happen 3 units away from the axis. If I would have picked a 4, that's going to tell me what's going to happen 4 units away. But the thing is, the further away I get, the bigger my graph is going to get. So.
Do you choose it from the columns?
Huh?
You choose it in the columns, or you just choose one at random?
Here, watch. Here. Can we just keep on going and then we'll. All right. Huh? You can go back and watch it. Look, this one here, the graph is already here for us. Okay, but we're well, let's see there. Let's answer these really quick. Where's the vertex here?
-2,
-2, -1. Good. Well, therefore, what would be the axis of symmetry, even though it's not drawn? What would the axis? No. X equals -2. What's the domain?
Negative.
Always negative infinity to positive infinity. What's the range here? And we have to go from least to greatest.
Oh, no.
Actually,
No, it's
How low is this graph going?
negative.
Yeah, negative infinity, forever down. How high is it going?
-1.
-1 with a bracket. Is this opening up or down? It is going down. Does this have a minimum or a maximum? It has a maximum because the minimum is negative infinity, the vertex is at the top. And where is this crossing the y-axis?
-4 or -9.
At -9. Let's do one more like that. Where's the vertex here?
-4. No, 1 -4.
At 1, -4. Good. What's the axis of symmetry?
-1. I'm in +1.
Good. And well, it's not just that. You have to write x equals +1. Domain is still going to be negative infinity to positive infinity. Now the one that's a little harder to understand. What's the range here? It does go from -4 with a bracket up to positive infinity. It's opening up or down. Is the vertex a minimum or a maximum? It is not a maximum. The vertex is at the bottom, so it's a minimum. And the y-intercept here is 0, -2. Let's see if I can get 2 graphs done. I can. So watch here, let's do this one. Now this is going to be just graphing. It's in standard form, so let's identify A, B, and C. Let's just come up with the 5 points. One of them here is given to me for free. I know this is going to cross the y-axis at -3 because of C. What else do I know by looking at A, B, and C? What else do I know about the parabola that's important? Yeah, is it going to open up or down? This is going to go down. But the big thing is I need the vertex. Okay, I need the vertex. So, see, -1, 4, and -1, 4, -3. Okay. So let's find H. H is equal to -b over 2a, which is going to be -4 over 2 times -1, which is -4 over -2, which is 2. In order to find k, 2 is the number I'm going to plug in. -1, 4, and -3, right?
Sure.
No, drop down to -1. Multiply. That gives me -2. 4 minus 2 is 2. Multiply. 2 times 2 is 4. And then I get 1. Why are we packing up already? So K is 1.
The last number that you're writing?
Yeah, the last number is always going to be K. So my axis of symmetry, Taiwan, just be quiet. No, he's going to be quiet, Hope. He's not going to say anything. That's what be quiet means. And then when you follow directions, you don't have to call me rude. I won't be rude. All right, so that's my axis of symmetry. This problem here might help you understand the last one, right? Where you were a little bit, well, how did I get to 2? Watch. I know my vertex is going to be at 2, 1, right? So that's here. I'm looking for 5 points, right?
Yeah.
The y-intercept, how far away is it from the axis? 2. So if I go 2 on the other side, well, now I have my 3rd point. But Mr. Romero would like 2 more points, right?
Yeah.
I've already used up points that are 2 units away from the axis. So if I wanted to come up with 2 more points, my options would be to go 1 away. That's fine. That's still available. On the last one, I already used up 1 away. I could use a 1. I can't use a 2. I've already used up a 2, but I can go 3, I can go 4, I can go 5. But the further away I go, the more space I'm going to need to fit the points. Maybe not so much left or right, but up or down, these can get pretty big pretty fast. So I'm just going to use the 1. Okay, so if I use 1, you got to get that 1. And what that 1 means is 1 left or 1 right. It doesn't matter, either one. Okay, you have to square it, which gives me 1, and then multiply it times a, which a was -1.
Yeah.
So 1 times -1 is -1. So this tells me if I go either 1 left or right, I have to go 1 down. That's what -1 means.
Why did you, what?
The reason why you square it is because it's quadratic.
The 1 times -1.
Because that's a. You have to also multiply times a.
No, 1. Like, what's 1?
1 squared is 1. 1 times 1 is 1.
So you got that from
So
somewhere.
start at the vertex, go 1 left, 1 down. Or you can go 1 right and 1 down. Notice how that's still symmetrical. And there's your parabola. Here, I can still fit in 1 more. Skip ahead to, no, go back and catch it on the video.
I don't have them.
Here we go, let's skip to this one. What I like about this one is that when I identify A, B, and C, does this have a y-intercept? Yes. The problem is it's not going to fit on my graph. I don't have enough space to fit 20. Okay, so I'm going to have to find all the points myself. Let's first find the vertex. So h is -b, which is -12, over 2 times 2, which is going to be -3. When I plug in a -3, 2, 12, and 20, this I think also does a good job of showing you how to use synthetic substitution. drop down to 2. To get above the line, you multiply by Rapunzel here. Negative 3 times 2 is negative 6. That when you add it, that gives you 6. To get above the line, you multiply. 6 times negative 3 is? 6 times negative 3 is? Negative 18, which when you add gives you 2. So Jason, sure enough, is going to be 2. So my axis of symmetry is going to be at negative 3. And then negative 3 and positive 2 is the vertex. I have 1 point down, but how many more do I have left? I gotta come up with all 4 points. So I'm just gonna use 1 and 2 to plug in. I'm gonna see what's happening 1 away and 2 away from the vertex. I also know from A that this is gonna open up. So let's see. 1 squared and 2 squared. What's 1 squared? What's 2 squared? And each of those need to be multiplied by A. A was 2. So this is 8 and 2. So if I go 1 to the left or right, I have to go 2 up. If I go 2 to the left or right, I have to go 8 up. So from the vertex, 1 right means 2 up. 1 left means 2 up. Notice how there's a reflection. One is a reflection of the other one. If I go 2 to the right, that means 8 up. And I actually run out of space on this one. 1, 2, 3, 4, 5, 6, 7, 8. So then it would be somewhere like around there. It would be the next line up. I just ran out of space. And then if I went 2 to the left in the vertex, 1, 2, 3, 4, 5, 6, 7, 8. Again, it would be there. And here is my fax machine. Priorities. All right, on Monday we move on to vertex.